What's up, everybody? Welcome back. Today we are looking at using Twitch accounts to log into our website. And the context is we are working on this collaborative Rube Goldberg machine website. And the idea is that each environment where these balls are like being thrown around in is controlled by some WebAssembly module, right? So what you're seeing here is like a WebAssembly module is loaded in our client, and it's like moving these platforms back and forth. But a WebAssembly module is, that same WebAssembly module is also being loaded on the server, and it's handling like physics interactions, right? So it detects when a ball collides with a platform, and then applies the correct like impulse response to make sure that the ball bounces off and does whatever it needs to do, right? And so the idea is that like once we like finish flushing this thing out, users should be able to upload chambers, and they will like stitch together to make some sort of like complex machine. That's the idea. And so today we want to look at, well, if a user were to upload something, they need some way to like look at what they've uploaded, some way for us to like attribute, for us to attribute. I think it's attribute. Which module came from which person, right? So like maybe on the screen we'll like put their like Twitch handle on top or something, and we want like some form of like punishment for if somebody does something wrong, right? So we want like abilities to like ban people, as well as like maybe like rate limit the frequency with which somebody can like upload stuff to our service under new accounts. And so the idea is that like we can use Twitch and OpenID, which is like a thing that it supports, to basically say, okay, a user, in order to authenticate with us, will go to Twitch, and Twitch will tell us, hey, like this guy's good to go, and here is like his unique ID. And then we can use that to do whatever the fuck we want, right? And so, yeah, that's the plan for today, is try to like start implementing that. Yesterday, we kind of poked around with this OpenID Connect flow, and we were pretty fucking lost, I won't lie. But I think that like I kind of have a good handle on it now to some extent. A good enough handle, I should say. So what's gonna happen is we're gonna have like a server. And this server is going to be like our web server at like spheraphoria.dev, right? We are going to serve some sort of web page to a client. And this is going to also be like spheraphoria.dev, right? There's going to be like a little button on this client that says like, you know, it's going to be like, have like the little Twitch logo here and say like, it's going to be like purple, right? And it's going to say like, log in with Twitch. The user's going to click that button, right? When they click that button, they go over to Twitch's website, Twitch. And Twitch shows this dialogue that's like, here, hold on, we'll expand this down a little bit. Twitch shows this dialogue that's like, you know, auth question mark? Like, do you trust this person? And then there's like a good button and a bad button. And if they click the good button, they basically get redirected back to our website with like code. And then they tell us, it's kind of like they're redirected here. Yeah. They're redirected here with like code. And then we like validate that code and serve something back up here. And what we do once we get that code, keep in mind that this is still from the user, is that we use that code to talk to Twitch's like auth servers directly. And we say like, who the fuck is this? Like, we just have like a number. It's like 50. Like, who's 50? And it's not even like who's 50. It's like, here is a unique code that is tied to this user so that I can get some authentication data, right? And then Twitch will send us something back. Now, this is all right now, everything we've said so far is common between the concept of OAuth and OpenID. Where the things get a little different with OpenID is that instead of this being like token, and us being like using that token to be like user, right? So we can be like, hey, who is this user given that I have this token? Instead, it gives us back token plus ID. And this ID is this like weird fucking format that like I'll just say I don't really get why it is this way, right? But what it is, it's like 3 chunks. We have like chunk 1, chunk 2, and chunk 3. All of these 3 chunks are base 64 URL encoded. I didn't know what that was before yesterday, but like essentially it's just base 64, which is like, I actually don't even really understand what that is. I think base 64 is like you take a bucket of bytes and you basically like re-encode that same data in a 64 character limit, right? So instead of you having like 255 characters per byte, you have 64 characters, and that byte has to be split up across multiple characters, right? So they create this thing, base64 URL encoded is just like the same, like the 64 characters used in base64 are not valid for URLs. So they just kind of swap some of them out. So this guy has like a header. This guy is like the actual data we care about, data. And this guy's like signature. So the header tells us basically like what the parameters that were used to generate the signature were. The center is like the actual thing we care about, and the third part is the signature. And what we were looking at yesterday was trying to like figure out how to verify this thing, which we eventually kind of got with like command line utilities. We didn't quite get all the way there, but I understand it a lot better now. I was doing a lot of like off-screen Googling. And I think what it is this header is going to say like RSA and SAW 256. And it's going to like tell us this. And we say, okay, so Twitch and like key one. So it's saying like Twitch encrypted this with key 1 using an RSA key with like, it doesn't encrypt like the whole message. Instead of encrypting the whole message, it takes a SHA 256, which is just like, you know, a cryptographic way of transforming input data into like a constant size. And it encrypts that. And I'm saying encrypt instead of sign because in my head, it makes more sense that way. I know I'm not using the terminology quite correctly, but the idea of like encryption and signing is just the same thing but backwards, right? So by they encrypt this SHA with their public key, and so any change that's made to the data will like heavily change this SHA sum, which will heavily change the output of encryption of that thing through RSA. We then go to Twitch, like OpenID Connect or something. It's like, it's not quite that. It's like, but it's OpenID Connect, which will tell us at some point, like it'll give us like this JSON blob, and in that JSON blob, there's like key URL. And if we go to that URL, we'll get a bunch of keys that like have IDs on them, right? So we'll get like this blob that says like, you know, key one, and I have like RSA key parameters N, you know, which is like some big string, and E, which is some big string. And I yesterday had forgotten my RSA stuff, so we were struggling with this a little bit. But the idea here is just that RSA is this like just mathematical transformation that is based off of message, approximately, I'm skipping over some details there, but message to the power of exponent mod number is essentially, this is like the transformation. And the idea is that if you do this one way with like exponent E, you get like an encrypted message. And then to reverse the thing, you just run the same shit again, but you swap out E for like, I don't know, I think they call it like D for decryption, E for encryption, D for decryption. And so what they are giving us here in this blob is like the parameters that we need to initialize an RSA thing. And then once we have done all this, we can basically say, hey, if we go through the same fucking steps, right? We SHA 256 our data, and then we decrypt your message. Is that the same SHA sum? That's all that we're doing. It took me so fucking long to figure this out yesterday, and we were getting kind of like lost in the weeds. But off screen, I kind of like made sure that I understand all of these components with like this shitty little Python script. And I will say that for next time, we should be using the openssl stuff on the command line was way harder to grok than like this stuff, because there's all sorts of like questions when you're using bash and programs about like, well, do they expect like new lines? These like inputs have to be files. How do I convert this like bucket of bytes or hex string into like the, you know, the parameters they expect? All of that's like way harder than just like doing it in Python. But I've got it all here where basically I use this like cryptography module to instantiate. Okay, here we go. We ask for like that OpenID configuration using like a little HTTP-YET, and then we look at the URL. We extract the parameters that we care about here, where by like, you know, N and E are just like the prime and the mod. And then I like construct this RSA public key out of that thing. Here's like the token that Twitch gave us. This is like the thing that we're trying to validate with the actual info in it. And in here I say like, okay, like here's the message, here is the header. And if we like verify this thing with the parameters that they say to verify with, we get the right answer, right? So if I go in Python test py, we see a signature is valid. We also see like here is like their key information. You know, we've proven to ourselves that we kind of understand it. And I cheated a little bit, and off screen I looked at the openssl RSA verification stuff. And I asked ChatGPT, how the fuck do I RSA verify based off of these like two numbers? And it kind of gave me some like deprecated APIs. So we're gonna have to like sort that out a little bit. But I took the output of some of like the stuff in the Python script, and I just kind of like shoved it in here, and proved to myself that both with the Python cryptography module and with openssl, I can like verify that this string is correct, right? So if I gcc-o this thing, I run test, I get like a signature is valid. So we have all of the pieces in place to verify this JSON web token, which is like kind of like what this whole thing hinges on. Now, I will say, I'm like 94% sure that we don't need to fucking verify this JSON web token. But because, you know, you hear so often that we're like, security is scary, and like, you know, rolling your own crypto is like really dangerous, and you're gonna miss some sort of subtlety that's really important, and that's why you have to do it this way. I'm gonna do it anyways, but I'm like pretty fucking sure it doesn't matter, right? Because this code that we're verifying, like, what are we asking when we verify this? We're saying like, hey, we look at like Twitch's signing key, and we're saying like, if Twitch sent us this message and it wasn't tampered with, right? All of the stuff inside should be exactly the same as what Twitch said it was, right? But we got the fucking message over an HTTPS connection with Twitch. So like, we already are fucking sure that Twitch isn't like, that Twitch is who they say they are. And so like, what is this extra token verification getting us, right? Because like, if they just give us the blob, we're like, okay, so Twitch sent us this blob, but we need to be like double sure it came from Twitch. But we were already sure, but let's make sure again. And so, you know, we're kind of in the state where I'm like, we're taking on all this complexity because I don't fully understand and can't confidently say to myself that technically somebody could use a fake cert for Twitch to trick you. Yeah, but then if they did that, I mean, if they used a fake cert for Twitch and man in the middled me, I'm getting the key that Twitch used to sign from Twitch as well, right? So like, what's the fucking difference? Right? They would just fill out the well-known key thing just differently, and they would sign the same thing differently, right? But I get that there are like some edge cases there, but also my threat model is that I want to make sure that like this person up here is who they say they are, right? And so like, if somebody is like swapping out certs on my fucking box, I'm fucked, right? I'm fucked anyways. And so like, the only thing I really need to worry about is that like this code comes from who it says they are, but also like, if this person manages to get a different code for another user, like from this channel, like who am I to say that they're wrong, right? Like, I don't know. Like, I think my gut says that there's no like real threat model that I need to worry about here. But you know, we're gonna do it anyways. What's the website? It's not live yet, but we're making this like collaborative Rube Goldberg machine here, something like this, where users are going to be able to upload pieces of like these like this like large chamber that like, you know, these two chambers are not connected right now, but they will be, and the idea is that users will like make chambers and upload them. That's the idea. Anyways, enough rambling. Let's just fucking jump into it. So I think the plan of action is to like kind of take this verification stuff that we've kind of played with in C and in Python, and we're gonna have to like make this in Zig where like our app is being used. Then we're gonna have to like actually look at like what this, like the content of this message. Once we've verified that it's sane, then we can look at the content of it. Once we have the content of it, then we should have some sort of like token that represents like who our user is. And so we're gonna need to like on our web client, like expose that somehow, right? The page is gonna have to say somewhere, hey, I am Spheriphoria, and like tie that maybe to like chambers that have been uploaded and stuff. We haven't really got there yet, but we'll have to have at least some sort of like user info endpoint. And then if we have that, then we're going to have to like create some sort of cookies, yum cookies. I like cookies. But like, you know, to make sure that like a login is persistent in some way. And then once we have that, then we'll probably, I doubt we're going to get that far today, but if we do, then we'll start looking at like database integration, right? So if we have a session key stored in RAM, and then our server goes down and comes back up, the user has to relog in, it would be nice if like our user info kind of was like persistent in some way, shape, or form. That is the plan. Long-winded explanation, but there was a lot of context to ramp up on. And you know, it's all here. Most of the context is here again if you guys are like trying to remember what the fuck is going on. Okay. So I think that maybe we will start off with like a user info zig file or something. And as we start, let's kind of kill this. We don't need this page anymore. Exit, 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 and let's kind of like start with a little main function. Even though this is going to be a library integrated into our real app later, it's kind of nice sometimes to start with like a little toy executable to figure out where we want to start. I should write down the time here. This is about like 15:00 maybe. And this is going to do something. He's almost certainly going to need the standard library in some way. And let's kind of like maybe start by just looking at this web token and trying to like poke around at it in some way. So I think I'm actually going to swap the order of these things. Let's start by parsing the message so that we can know that we have like a piece of information that we're good with. Then we can like look at signature verification. Okay, so we had our test pi. Here is our ID token. So let's just kind of like yoinkies this shit and slap it in here. So we'll just call this ID token. And let's just start trying to work with this thing in some way. So we have, maybe we're gonna want some sort of token abstraction. Probably, almost certainly. We're gonna wanna like parse this thing out from a chunk of data. So JWT, I guess we'll call it. Maybe we'll call this a JWT token. JWT token is like saying ATM machine. You don't want to duplicate, so JSON web token, we'll call it. And this is going to return a JSON web token. And the components of this thing are going to be like header, message, and signature is probably just going to be like a bucket of bytes. There's a real chance that this bucket of bytes is always going to be the same size, but I'm not positive, so we'll use it as like we'll leave it as like user allocated, or sorry, runtime allocated, I should say. Okay. So I guess what we can do is we can start by just like running our test script and kind of like copy pasting the format out. So here we're expecting this thing to look like this. This is the header we're expecting. And we have the message we are expecting to look something like, oh, sorry, this is the message? This is the header? No, this is the key. This is the header, sorry. This one's the header here. Under the thing that says header in all caps. There we go. And then we have message is something like this. Yoink. We can be like pretty specific here. We don't really have to worry too much about like, what if some of these fields are optional, blah, 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 because we are only working with Twitch, and if Twitch changes like which algorithms it uses and stuff like that, then we're gonna be fucked anyways, so. We'll just do it like this. Algorithm type is another string, and ID is probably gonna be usize. I guess this is going to be a string as well, actually. Because I think that, like, this is quoted, which means that we can't really guarantee, and all we have to do is compare that the ID matches the ID of our, like, other thing, like, which key we get. So I guess technically if they named their keys with words instead of numbers, it would still all work, if we could just do, like, a string comparison. This is going to have odd, x, IAT, ISS, sub, ASB, nonce, and preferred username. Now, I just want to say, I was reading OpenID Connect's webpage yesterday, and I was cracking up so much. Where does it say? Hold on. I saw it somewhere. Somewhere I saw on their website that they're like, oh, yeah, why would I use this? Well, it's like a simple way to authenticate. I'm like, bro, you're telling me you look at this fucking struct and you're saying this is simple? Fuck no. This is not. Fuck no. Like, do you think anyone could look at this and tell you what it is? Like, surely not, right? Like, what the? Name your fields. Okay, it's fine. Anyways, uh, okay. So let's parse this thing. So header is going to be basically like from the beginning of this thing to the first dot, right? So they have a dot here and a dot here. These are like the separators. And so we can just do maybe like std mem index of scalar, and we look at the JSON web token, and we're looking for a dot. And this, I assume, can return null. So I guess if this does not succeed, like we don't find anything, we'll just say return error invalid. Yo, how you doing? I'm doing good. How are you? We're gonna do the same thing here, where we're looking at the message offset is going to be this thing from header offset +1 onwards. We're looking for a dot again. Actually, I wonder, do we have like an iterator function in the standard library where we can just like iterate over indexes of dots? That'd be kind of cool. That would be kind of cool. So Zig standard library. I assume that this would be in like the memory module, and they do have like split iterator, which is almost exactly what I want. So here returns an iterator that iterates over slices of the buffer that are separated by any item in delimiters. So here we just want like split scalar, probably. Split backwards, split scalar, yeah. Cool. So const var it is this thing, except we are going to use split scalar. And this takes in a buffer, a delimiter, and he returns a split iterator, and we're chilling. Okay. So we can just say for 0 to 3, right? We could iterate over, we could like use the iterator as our like loop condition, but really we are expecting exactly 3 elements here. So we should just do it, you like use this that way. So we'll say this is index I. How do I want to handle this? I guess, let me think. Maybe it makes more sense to do like var components is 3 slices. And then we can iterate over components by pointer. Component, I think this is right. And we can basically just say component is equal to it next, or else, I'm assuming that this returns an optional, yep. Or else we will return error invalid. And maybe like we could get a little fancy and say which thing is not set, but instead we will just bitch and moan, and it'll be up to someone else to figure it out. And then here we can do it next. If it next is not equal to null, i.e. there's more data, there's a problem. So we'll say error std log error. I guess here we could do this. We could do 0 ... and take in I. And then we could say std log error so 0th, 1st, 1th, or 2th component of JWT is not present. That's what we'll do. And then here we'll say more than 3 components in JWT. And return error invalid. There we go. There we go. Okay, so, oh, this, we need to write I here as well. Okay. This is never mutated, which is true. Well, no, it's not. Yeah, I guess maybe that is. It's surprising to me that this is viewed as not mutated. This might be a slight mistake. 1, 2, 3 instead of ith, 2th, 1st, 2nd, 3rd. Yeah, we could write component index like this, and then the English will be a little bit more correct. We are building on a Zig web server. Yeah, so we have our web server written in Zig already. We have like this server that goes on an event loop, and we will eventually hook this up together. But at first, I'm just gonna like build this little toy app, and then once the toy works correctly, then we can like integrate. I find that that's a little easier. Okay, so then all of this stuff can go away, and we can just basically try to base64 decode all three of them. So const header decoded is, I saw that in the standard library earlier today. There's like something, they have almost what we need. Base64 URL safe, something stood, base64 URL safe decoder. Can I like, is there like a decode, base64 decoder? Yeah, okay. So base64 URL safe decoder. Although this needs a, this is weird to me that this is capitalized. This feels wrong, but that's okay. It's okay, because this is an instance of this thing, so that's fine. Base64 decoder, and so here we should be able to call decode. And we're decoding into some destination slice. Dest_len must be what you get from calc size. I see. So we have const header size is equal to calc size for slice upper bound. I'm assuming one of these is way faster. I'm assuming this is like a way faster impl, right? So calc upper bound is they just take the length of the thing. I see. They basically just like divide by 4. Hand wavy. Source len over 4 times 3. Why times 3? Because nope. I don't know how base64 works well enough. I guess 64 is 3/4 of 256. Is that true? It's 1/4. So I don't know why they're multiplying by 3/4, but that's okay. I don't fucking care. We'll just trust that it's correct. Okay, so the upper bound is source length. I see. So we just pass in components 0 len. Okay. I don't really care if we overallocate a little bit. I guess yeah, I don't, because we're immediately going to parse this thing into another structure anyway. So we're not gonna have to worry about like freeing later or anything. Where did I just go? Hello? Here we go. Okay. So then we say const header buff is equal to, I guess we need an allocator, huh? Allocator. Which means that up here we need to say const allocator is equal to std mem allocator. Boom. And then here we can allocate u8 slice of header size. Boom. Which means that now when we decode, we can decode into header buff from components 0. Chillin'. And then this should be like a JSON blob. So let's start right now by just saying print. No, std debug print. Header is some string. And we'll print out the header decoded. I think this is enough that we should have some amount of progress that we should visualize before getting too fucking far into this thing. Okay, so what are we gonna do at this level? We're gonna create our like general purpose allocator. With I don't give a fuck config, default initialized. We're gonna say, hey, later, could you clean me up and warn me if there's any problems? Then we're gonna get our allocator out of this. I like naming this thing alloc. I think that my naming scheme is different here than everybody else's in the world, but I don't care. I should do better, but I don't want to. Okay, then we can just call JSON web token parse with ID token. We have to try this thing. And at the end of this, we have to probably return something. So return error unimplemented. Unimplemented. And here, when we parse, we have to pass in our allocator. Boom. Zig run source user info. He doesn't like that for some reason. Because I wrote const GPA instead of var GPA. He needs to be variable. Pointer capture of non-pointer type, so at 32 I have to write ampersand components here, which means that this was supposed to be var the whole time. Header size is wrong here, so calc size upper bound needs to be tried. Header buff is also has to be tried. You know, we could error out. And value of web token ignored. So here we'll just actually ignore it. Explicitly ignore it. Cannot format error union. Where the fuck am I trying to... Oh, this also has to be try, I guess. So many tries. No? Invalid string S. Oh, because this doesn't go into header decoded. This is header decoded. This header buff. Header decoded. There we go. And invalid padding. Okay, so I thought that I saw that this decoder... I thought that I saw that it was with padding. Because I thought I saw URL safe no pad. So I thought that this one would be fine. Oh, but I see, I had it backwards. I thought this one was safe to use with no padding. Or like that it would fix the padding for me. But it's the other way around. It's that I want to say that I have no padding. Invalid padding still. So the no padding is just a fucking lie, I guess. Is that true? No pad. Decoder with ignorer. Am I supposed to ignore... What is this? Decoder with ignorer. Do I have a debugger? Yep. I sure do, but I don't feel like I need to reach for it right now. I just want to read. I want to read. What is it supposed to be doing? I see. So here they have pad character is null, but then also here they're saying pad character is null. Oh, so are they maybe saying that with no padding, if there isn't the padding that we need, it's not good. I see. If the pad character is not null, otherwise, oh, I see. So in both cases, the padding, like there is still invalid padding. I see. I thought it would like correct the padding for me, but I guess it won't. So we have to do that ourselves. So what we should do here, this is kind of nasty. But I think that what we have to do is we need to make this thing that's like modifiable in some way. So we have like this, these guys right now are just references to the data in JWT, right? So we have this like 1, 2, ASDF, ASDF, dot, ASDF, ASDF, like something that looks like this, right? Not quite like that, but close enough. And we're kind of saying that we want to start like shoving some equals characters on here to like pad it out like base 64 expects. Which means that instead of like using these things directly, we actually have to copy them out. And I think probably what makes most sense is to copy them into array lists, and then in our array lists we can just like append equals as much as we need to. Which will make these guys look more like array list U8. And I guess for all of these guys, we should now, instead of having them like undefined, we'll initialize them. So I think that you can do like, you know, we have one std array list U8. Fuck. There we go. It's so hard to type sometimes. And this is going to be, how do I do this? Std array list u8.init alloc, and then I multiply this by 3. I feel like I've probably been like overly explicit here. We probably don't need all of these things. Like surely this can we go away? And probably one of the, like maybe we can get rid of this if we write an underscore here, because it's like it will infer what the argument is here. I think that's right. Now instead of this being like component.star equals, we're gonna say copy from slice, which it's not really resolving nicely. But that's okay. So we'll call this const s is equal to this, and then components copy from slice, and like we'll just let the compiler yell at us in a second to tell us what we did wrong. Component, and I guess now we don't need to iterate these. Sorry, yeah, this is right. S like this. Okay, what's it bitching about? Oh, it's fine. Oh no, it's not fine. That's the wrong command. Oh, I see. He doesn't like this comment here. That's crazy. He doesn't like this. That sucks. So I guess we'll put this double name thing back. Unused capture components. Right, because this is a component copy from slice. And it is the right type. I got it wrong. It's like append slice maybe. I don't know why it's not auto-completing for me, but fuck it. Components 0.len. So these now have this has to be items here. And components 0 at 47. This would be components 0 items to extract the internal data of the array list, and we're chilling. Okay, so is there really no like auto infer type info here? Is this really how I have to do it? This feels gross, to be honest. If any ziggers are in chat, I'm not saying that word again. If any Zig users are in chat that understand if there's a better way to do this, I'd be interested in hearing it. Do you use arrows or HJKL? HJKL, I use probably HJKL, the word jump ones a lot. I use F a lot as well as just like searching. Right, like here I'm jumping around with like W and B. I do that a lot. Zero and $sign and caret I use a lot as well. Can I be any of your assistants if you want help in it? If you're asking if you can type stuff in chat, yeah, you can ask whatever you want. You can say whatever you want. I don't really mind backseating that much, but you know, I will say that if I ignore you, that's just because I feel like I get to choose what is in the video and what is not. And so like if you like nag me to answer you, I'll find that annoying. But otherwise it's probably fine. As long as you're just like not being fucking weird. Okay. So now what we can do is we can like pad each component. So we can say like while component, we can calculate maybe component items len mod 4. So I think that if I remember correctly, base64 is supposed to be 4. It's always supposed to be like a multiple of 4. And so I think that the amount to add is like 4 minus this thing mod 4 again. This is how I always do it. I don't know if I'm like missing some sort of like math that makes this less shit. But when I do it, when I do it this way, I'm thinking like, okay, so if there's one element over the limit, then this will give me 1. Then I need to add 3, so I need to subtract 4 minus 1 is 3. But then if it like lines up perfectly at 0, then this will give me 4 minus 0 is 4, which is wrong. It should be 0, so I need to mod by 4 again to make sure that like if it's 4, it goes back to 0. So num padding cars needed, and then we can say for num padding cars needed. Component append equals. There's probably some like intelligent way to avoid this loop and just like batch it all at once, but I don't want to figure that out. Right? You could like switch 1, 2, 3, 4, but I'm hoping that it doesn't fucking matter. What the fuck did I just click? Holy. Okay, it's fine. Okay. So then this padding thing should go away. Everybody is complaining so much about all of this like leaked shit. Fine. So for components, component D in it. Fine. We'll clean up our memory if that's what you're gonna fucking complain about. It doesn't like this leak here as well, where here our header decoded should be alloc free header decoded. All right. There we go. Okay. Oh, sick. There's our header. Hell yeah, baby. Okay, so now what we want to do is we want to turn that into this header struct here, which I think is just a simple std json parse from token source. Let me think about this. Yeah, we do have to, I think parse from token source makes sense. Unless there's a way to parse from a string directly. JSON. Okay, what do we have in here? Parse from slice. That makes way more fucking sense. Parse from slice. So here we are trying to parse out a header. We need an allocator. And we need a string to parse. So this is going to be our header decoded. And our options are I don't give a fuck. This certainly is failable if it's taking an allocator. Yep. And here we'll say const parsed is equal to this. Defer, I guess we'll call this header parsed. Defer header parsed dinit. Ooh. So I think that what the decoder does here is it's going to give us strings. How do I say this? So I think that it gives us references to the strings in this header decoded buff. So I think that if I just store this thing, I'm going to be pointing to invalid memory. I'm actually not entirely sure about that. But I do believe that's how it works. Sometimes it copies stuff, but only if it needs to, if I remember correctly. Parse from slice. Parses the document and returns a parse. You must call DNet on the returned object to clean up leaky resources. Note that buffer underrun. It doesn't really say. I'm pretty fucking sure. What we can actually do to confirm is we can print header or std debug print. We can look at header parsed. I think it's value, I think, is what's in there, and we can just look at alg, right? And we can say where the fuck is this thing? Parsed. And then we can also just print out the header decoded and see if those are almost the same fucking value. Fuck. Really? Does that not work? Oh, is it this one needs to have an ampersand? No, these are both pointers. Expected 2. Oh, I need to put this in this thing. There we go. Much better. Why is it not printing? Oh, because we returned error? No? Why isn't it printing? Am I high? Did I not save? Save? Hello? Am I fucking nuts? Unknown field. Oh, it's failing to parse. Because it has alg tip kid, and we have alg tip ID. Oopies. Error, syntax error? In the JSON? That's surprising. Where is the syntax error? Parse from token source leaky, skip whitespace, check end. And if stack height is not equal to, if the stack height is 0, return syntax error. Interesting. Does it not make sense that Zig would have a way to combine variable declaration alloc init and also dealloc when scope ends in a single piece of syntax? I haven't really had a problem with the syntax it has right now. Tangent, emit H should actually be usable soon. Oh, this is the C binding stuff. I'm down to look at this tangent. Because yeah, when I looked at emit H, it was pretty not what I wanted. Do they have an example of the output here? See the current results here. Dude. Come on, you man. They do stuff that's include zig.h. So I think that personally, I would want to see that something that can be done without this, right? Because this kind of like makes your external API like depend on Zig. But I understand like what I'm looking for isn't necessarily like what the goal of emit H is, right? But this does look like kind of nice, to be honest. To be honest, that does look kind of nice. So why the fuck isn't this parsing? I'm pretty like, is this not valid JSON? Am I like fucking high? We printed out header decoded. And this looks like valid JSON to me. Skip whitespace, check end. Like, am I high? Can we maybe put this in quotes just to see if we're missing anything stupid? Parse from slice, parses this, and looks like our parse options. Oh, we could use allocate as well to avoid that thing that we were talking about earlier. So let's do that. Expected type alloc when got pool. Oops. What is it supposed to be? What is it supposed to be? Not that this is like the problem, but I'm getting, you know, a little sidetracked. Alloc when always. All right. So assert end of document equals scanner or reader next. Try skip whitespace check end. Okay. Is it possible that like this is using some sort of like bullshit braces? Self stack height equals 0. So can we like maybe GDB this thing? Zig build exe. Let's actually stick it in our build script. This will be nicer. So let's just do this. We'll call this user info. This comes from user info Zig, and we install artifact user info Zig builds. This should be built now. Build and Zig out bin user info. Okay, there. Now we can run this with GDB easily. We can just say GDB args. And can we break here? Like, can I just fucking huck this in here? Break this? Nice. Okay. So what is going on here? We're at self stack height 0. And what error were we getting? We were getting syntax error. Okay. Can we look at this? No. P self. Stack bytes length 1. Okay. Items is like a empty string. It would be nice to like maybe like get a feel for so we have object opener, key value, comma, key value, comma, key value, and brace. I feel like I'm like missing something really fucking obvious, to be honest. That GDB didn't feel like it was helping me. Did not feel like it was helping. I didn't like free header decoded. No, it looked fine in GDB. Like the content of that thing was totally reasonable. Can we maybe like, okay, we're gonna get crazy here. We're gonna get crazy. Okay. We are going to literally, I'm worried about like character encoding or some like something fucking stupid. So I'm going to retype this thing out manually. Because I'm not convinced, because it like looks really fine to me, and I feel like doing this will give me some amount of confidence. So maybe we'll actually do this. Let's go into Python. And let's just do JSON loads this thing, right? Let's just like fucking really hammer home that this is fine if we parse it with another parser. If it's not fine, then we can be like, why am I stupid? But let's just start here. Print this. Sys exit 0. Python 3 test py. Okay, that's fine. Okay, now can we copy paste this exact thing? We didn't retype it out. We're just like, maybe they have some weird character encoding bullshit going on. So we do the same thing. Actually, let's keep the thing that we just deleted as maybe commented out so that we can come back to this in a second. But now we're going to do this one, which is just we copied and pasted it out of GDB. We have to escape the quotes again. Yep. 1, 2. Okay. That's fine too. So it's not like they're like using like invalid characters. Let's try swapping out like the header that it's trying to match with a stud JSON value. Like just in case. I don't think that there's any reason that this would be a problem. But you know, let's just double check. No field name allogen value, right? So let's just maybe print out any of the header parsed value. Let's just kind of see if it says something same. Yeah, so it is still seeing syntax error. Very interesting. Very interesting. So can we, if the Python parser is parsing it fine, what if we just like copy this string and parse that directly instead of using what we get out of the base64 decode? Right? Let's just bisect until we found the right answer. So that parses fine, which is very interesting. Very, very interesting. What the fuck is going on there? It's almost like, I wonder if we have to like trim this shit. How many, so let's maybe say print header length is header decoded len. Null bytes, yeah, it does feel likely, huh? So this is 39. And if we go into Python land and we take this thing, can we say like print len this? Python test py. 37. Yeah, it's just like a fucking bug. So let's maybe look at what it looks like if we don't print it as a string. It has 170s at the end. What is ASCII 170? ASCII doesn't go up to 170. 170 is 0xAA. Oh, fuck me. Oh, right, of course. Oh, thank God. I'm just gonna say it. I think it's sick that Zig put 0xAAs in there. That's so sick. So this is just gonna tell me the length, probably, and I just like ignored it. It doesn't tell me the length. So what the fuck is the point of using calc size upper bound? I kind of assumed that this would like fill us in later. Okay, fine. Fine, we'll just calculate the actual length. Fine, if that's what you want, that's what you want. Oh, there we go, we're chilling. No, we're not, because I'm not using the right thing here. This is supposed to be from header decoded. Alright, okay, that's fine. Oops. I wonder what the point of calc size upper bound is then. Because, like, surely the decode thing, like, could tell us how long it is. And so I assume that the point was that the workflow was to get, like, a big thing that was, like, cheaper to calculate. But I guess, I don't know. And then, like, truncate it later. But I guess that's not the case. I guess you could like null terminate your thing. You could like pre-jack your output with zeros, and then it would maybe figure it out, but whatever. Whatever, it's fine. Okay, so we are going to do the same thing, but for the other thing, the message, right? So I guess this is gonna like function base 64 decode. And this is gonna give me, we basically want this. So this is gonna give us a bucket of bytes. Yeah. And our input is also a bucket of bytes. Yeah. And maybe we'll just call this like JWT decode or something, because I don't want to like, this is like base 64 URL encoded, no padding decode. It's like, I don't want to, we'll call it JWT. JWT segment decode. I like that. So this becomes data here. We need our allocator. And this becomes data. This is just size, not header size. This is decoded. And then this is return decoded. And then we have to do an error defer here instead of a defer. Chillin'. And then up here, we can just say const header decoded is equal to JWT segment decode with our allocator and our components. 0 items, boom. Here we defer alloc.free header decoded. And then this stuff stays the same. And then we do the same thing for the message. Message parsed. Parsed. There we go. And this is a message. And then we should be able to look at message parsed value. All right. Which means, and then the last piece is the signature, so we can just do that now as well. Signature is equal to this, and here we only error defer alloc free signature because we're trying to stash that late for later. Which means that we should have everything we need to return message equal to message parse message value. Parse value here. Header should be header parsed value, and the signature is signature. Now, I'm actually not 100% sure here. We asked the parser to allocate the stuff, but I don't know if like by calling dinit on the parsed segment, if we're gonna actually like free that memory when we didn't want to. So we need to double check that. What the fuck is going on? Oh, I see. I was trying to delete this like empty line, but it wasn't an empty line. It was just a one character end of line. Oopies. Okay, so let's maybe look at what this thing does. So if we see, maybe we go in here and we look for alloc always. We could kind of see, this determines whether strings will be copied or if a reference is given the buffer, blah, blah, blah. It's not clear. But we can maybe look at, so the parsed thing that it gets is, keeps like an arena allocator, which will like free everything nested. So we can maybe look for like where that arena is created. It's not created here. This guy gets a arena allocated correct arena created immediately. And then they use the arena allocator. The only allocator that this guy has is the arena. So we actually cannot, it'll duplicate the strings, yes, but I think that it will duplicate the strings and attach them to this allocator. So if we call header parsed dinit here, this is going to free this arena. So even though we asked it to copy this stuff out, it's not actually copied out, if that makes sense. But So instead what we want to do is we actually have to like manually copy that shit out, which is a little frustrating. But it's not the end of the world. Not the end of the world. So I guess we will maybe make like clone method on this thing. And we will clone it with an allocator. And we were basically saying, let's do, oh, should we get crazy? Let's get crazy. We can say for each field in self. Oh yeah, let's get fucking wild with it. Maybe don't pass alloc always and free the original strings earlier on. That's yeah, I did change that. I deleted the alloc always and I'll just free them after. Be fine. So here we're gonna say alloc dot dupe self dot, I think it's field self field name. I think this is how we do this. So here we go over every single field and we duplicate them. But if any of these fail, we have to free all of the previous ones. Which is not as trivial to do with metaprogramming as I would have wanted. You have to like stash all of these things and then free all the ones that have been created later. So instead we will just copy. We will just do it by hand. Like fucking losers. Like fucking losers. But that's okay. So here we're basically gonna, we're gonna, for each thing, we're gonna say const this is equal to try alloc dupe the same thing, but from self. And then we're going to copy this word and error defer alloc free the thing we copied. No, the macro didn't work. We'll try again. So we turn this into a const, go to the end of the word, equals try alloc dupe, go to the word again, paste it, error defer alloc dot free, paste it again. There we go. Hell yeah, baby. Fuck, we forgot self on all these dupes. So we can fix that though. Could you skip duping them and do you pass the original JSON string to free it later on? Let's think about that. So we would maybe, we could actually maybe say, you could argue that like everything in here should be a reference to what is in the original token. Except I don't think that you can guarantee that this parse option will never allocate. It will only allocate if needed or always. And so I don't think that we can guarantee that the JSON parser won't allocate something. I don't know if we can guarantee that. So instead, I think this is fine. I don't really care. I'm fine with this. You know, it's not ideal, but it's fine. I've missed some primes, by the way. Natun, thank you for the prime, and K-Trace, thanks for the prime. Appreciate it, appreciate it. Okay, and then here we will just say return all of these things. So this is a message, and it's just all of these again. We will take it, blaze it, you know? So all these get dots. These go away. I guess we can just macro it. So QQ, add a dot, go to the end of the thing, find, oopsies, fuck, I fucked with the macro. Add a dot, find the end of the word, yank it, find the colon, equals, paste, delete, comma. Boom. Okay. Not ideal, but good enough, you know? We will live. And we do the same thing for the header. And it's kind of like the same thing, except this is alg. We have tip and kid. kid. There we go. And return alg equal alg. Tip. Tip is tip, and kid is kid. All right. And then I guess that means that all of these also need dinits. Which is not ideal, but it's good enough. So I guess we'll just kind of like yoink these and say, Alec, free this thing. And all of these guys have to have semicolons at the end. Boom. And these guys have to say self. Boom. Fuck me. There, like this. There we go. And we need to give the same treatment to this guy. Hooray! So much fucking boilerplate. So much boilerplate. Like, what have we even really done today? Parse a JSON message? What the fuck, man? Alec free self dot end of word and brace semicolon. There we go. All right. Okay, but at the very least, now this is sane. And I guess now for our JSON web token, we also need a function. Dinit. When you did the alg to kid replace op in your editor, what were the editor actions you had there? I think probably what I was doing is I retyped one, and then if I press dot, it like redoes the same action. So here I did like change in word, hello, and then down here I press dot and it does the same change in word, hello. Probably is what it was doing, but I don't really remember. We also have to copy the signature out, but the signature is chillin'. So I think that here we just say self header dinit. This is a, what is this thing? JSON web token. Message and alec.free signature. There we go. There we go. All right. All of that, but now we should have this thing. So here we should be able to do defer jwt dinit alec. FYI, the message parses the header now. I don't think that's true. Does it? Message parse. No, I don't think it does. I don't think it does. We'll see though. Debug print any jwt. I think it's fine, but we'll see. Fuck. No function named dinit with no e. I need an e on my dinit. Expected type this, found this. So here I need to write var so I can dinit him. Then on 153, there's a mistake. Because this guy needs to be able to return errors, which means that when we use these guys, we need to be able to write try on him. Here at 100, oopsies, we need to pass the allocator around. Where the fuck am I? 100. This needs alec, and that's fine. We have unknown field. Interesting. So this is coming from message parsed. Oh, you are right. You told me exactly what the problem was, and I ignored you. But you were correct. Thank you. Good eye, good eye. Unexpected token coming from message decoded. Interesting. Can we maybe look at what this thing is? Do we have to... We already fixed the like null shit at the end. What does this thing look like? This seems fine. Odd exp. Is it possible that like unexpected token is due to like one of the names not matching correctly? Let's make sure that we got all of these fields right. Hello? This one, there we go. AUD, EXP, IAT, ISS, SUB, AZP, NONCE, preferred username. There's a chance I typoed this, but I don't think I did. Yeah, I don't understand. Unexpected token. Oi, oi, oi. All right, let's print out a message decoded, I guess, as a bucket of bytes. This doesn't have trailing bullshit at the end like last time. I wish the error handling in this like JSON parser was a little bit nicer. I like really struggle. Okay, let's see if it's related to it being a message. So let's return error, maybe unreachable here. If, how do I want to handle this? If true, return error unimplemented. Then here we can try decoding into a JSON value. And if that succeeds, then we are in a place where it's related to the fields in our structure. So this comes from, dude, my brain. Message parsed value that we're trying to look at here. So it does look like the thing parses correctly. And it's related to this stuff. So let's start with, I think there's a field in the parser to be like, ignore unknown fields. Is it true? Let's just see if that fixes our thing. Unexpected token, so that doesn't help. Interesting. Interesting. What the fuck? Components 1 items. Trailing comma maybe? In like this, you think? No way. Oh, you think there's a trailing comma in like the message itself? But like the when I parse it into a value, it works fine. Can we print this as an object and just print out the keys and values? So can we do like what does this thing have on it? It's got object map. So this is just a string array hash map. Okay. So we can say for message parsed value object keys. I guess this is fine. K. We can print the key as well as the type of the value. Well, maybe we'll do K message parsed value object get key. Let's just see what that does. So here we got JSON dynamic value string integer. These things are integers. So exp and iat need to be I32. Usize maybe? I64 is probably the safest, which means that here we don't need to clone them or free them, and here we don't need to dupe them. Here we just say self IAT and self ISS. Aha, aha! If only the errors were nicer, you know? No field object. Yeah, so this goes away, and this goes away. Segmentation fault. That's interesting. What the fuck? Where is this? This is it printing the JSON web token? Whoa. Whoa. Interesting. So if we move this print here, I bet you it works. Then we're probably freeing some memory that we're trying to use. We log right here instead. Oh, so I don't want to run GB. Zig build. Okay. Let's see. Yeah, that works fine. Oh no, wait. There's still. So this worked okay. Mem set did not init here. Oh, because I'm a fucking dumbass. These, I implemented that clone thing, but I didn't use it anywhere. So I have to do it here and here. And then here, this should be fine. Oopies. Classic. Memory management's hard. Has anybody ever said that before? This is like kind of like a new thing that people didn't know about. This, I guess, can be clone, can use const. How are you pulling commands from history? So I'm using Control R to search backwards in history. And then I'm using Control X followed by Control E to open up the current command in my editor. So I think it's like the editor variable has nvim in it. And so if I type Control X, Control E, it opens up the current command line in that editor. And then I can use Control R to search. And those are all just like default bash commands. Those are all just default bash commands. Expected type that found that. Am I fucking stupid? Yes, I am. So the clone on the header has to return a header, and the clone on the message has to return a message. Thanks so much. That's awesome. Yeah, no problem. It's kind of sick. Wait, what the fuck? Member function expected 2 arguments, found 1. Oh, do all of these dupes need a U8 on them? They probably do, huh? Yeah, I found that like one of the things that I really liked about like working with other people is like sometimes you just see people do stuff and you're like, wow, I didn't know that you could do that, and now that I know it's possible, it's like fucking sick. And so it's cool that like somebody is seeing me do some action. And that's resulting in them being like, wait, I can do that too, and then like gaining some efficiency. That's pretty cool. Makes me happy. So then all of these places where I made this thing has to try here. And self exp at 60. Oops, did I not? Exp is an i64. Oh, fuck. I fucked up the wrong one. So this would be exp x iss here, and then x. This comes from iss, and this comes from self exp. Oopies. There we go. We're chilling. That took a while. A long time, actually, but we are there. So I think that we have something that's the same. Let's look at maybe printing these things as strings. So, it's fine. It's fine. I think that I'm fairly confident. Let's just print out, like, JWT message preferred username, just to make sure. But I'm pretty sure that this will write Spheriphoria. And then we can move on to actually validating this info. We took way longer than I feel like it should have to actually just get the fucking data out. That was like unbelievably long. But that's okay. I thought that we'd be spending most of our time honestly here. This was a shockingly long time, actually. Like, what the fuck? Why did that take so long? I'm gonna have to go back on the VOD and watch. Because this should not take an hour. That's insane. That's insane. So I did something like, I must have run into something fucking stupid. I don't know what, like probably I just spent too much time walking that JSON stuff, but it definitely should not take that long. On learning workflow from others, do you know about like :make and vim dispatch and stuff? Yeah. I've tried all that stuff before. I find that I don't think that it really gains me anything over just using make in the terminal, because I find that like setup for that stuff is like kind of harder, as well as like getting like the processing of the data into the quick fix list and stuff is like, it's a pain in my ass. And I don't really mind just punching in like line numbers, because like I feel like I can like navigate files pretty quickly, right? Like, so just like going to the file and punching in the line number doesn't bother me at all. I know it bothers people watching me, but it doesn't bother me myself. Okay, so let's validate the signature. I blame the clone dance. Yeah, that might have been a little rough. Are you using Telescope? Have you tried using Telescope? This is Telescope. Oops, wrong window. This is Telescope. So I use Telescope all the time. It's like probably like my one most needed Vim extension, I think. I used to use like some binds to do like this shit for you, but it's just not as easy. The default error format stuff does what you want. Yeah, I mean, I've just had other times where it doesn't do what I want, and I prefer consistency in workflow over like improvements for one, if that makes sense. Lowest common denominator, just make my whole life worse for some edge case. I do actually do believe that that's better though. Okay, so this thing's gonna need some sort of like verification. And we are going to verify basically just based off of the input JWT, right? And what we're gonna do is we're gonna like extract the signature, which we've kind of done below, but that's okay. We can do it again. And this is gonna be maybe like sig start or message end is going to be stud mem or find index of last index of scalar. That looks like what I want. So we're gonna take this thing and we're gonna look for a dot. And then we should say const sig is JWT from message end plus 1 onwards. And const message is from 0 to message end. Now we have to be careful here because, you know, what if message end plus 1 is out of bounds? So we're going to say like, this is going to return an error. And we're going to say like, if message end plus 1 is greater than or equal to JWT len, we return error invalid data. Then we are fine down here. This is chillin'. This is going to be or else the same shit where like if there's no dots in here, return invalid data. Then we need to do something with these things. So we can look at our maybe test.c. And maybe all of these things are using like deprecated APIs from what I like copy pasted from ChatGPT. But like maybe let's start there, integrate with Zig with the deprecated APIs from OpenSSL, and then come back and try again later. I looked briefly into like the Zig standard library. They do have primitives for like RSA, but it didn't look like to me that it was easy to use these things directly, right? Like they have like this concept of a public key, and like this thing has the components of a RSA thing, but it didn't feel like easy for me to use it, right? Like there was like also these like verify functions. But again, these are like pretty based around certificates. So I would have to like take the RSA components that I could have like a public key for, turn them into a certificate, and then like use it. And so I didn't really get it. And so like using this OpenSSL way feels pretty clear to me, right? It's kind of saying like we create an RSA object and we populate the N and the E fields. Simple. And then we call verify. I'm like, I get this. So I think we'll start here. Try to work into the like I have like a post on Stack Overflow being like, how do I get out of this like deprecated thing? So we can look at this as well after. But let's start here. We'll start here. So which means we're gonna have to need, you know, some sort of OpenSSL import. So here we'll see import, and I guess we'll just pull in all the same things that I pulled in my example. Cannot C import, it's a C include. Not bad. So this is RSA, SHA, and PEM, which I don't think we actually need all these. We probably can get away with RSA and SHA. But I will include all of them and then try that at the end. This stuff is, I think that all we need is this verify signature. And so we're just kind of like, yoinkies this shit. Yoinkies. And slap it here. And start just like pulling out, you know, doing like the C conversion. So const RSA is C RSA new. This is C big num new. This is C big num new. We don't need to make this int here. These are C functions that are taking in our, I see in our example, they were hex encoded. Oh, we actually don't have the parameters here, so we should get them. So we have a key. We'll have, I guess we'll just say that we have n, which is going to be a bucket of bytes, I guess, and e is also going to be a bucket of bytes. And I guess we are using like hex to bin. I wonder if there is a way, like, I don't want them necessarily to be hex encoded. I guess it's fine if they are. Yeah, we'll leave them hex encoded. Fuck it. N hex. Hex. And then we can just use these functions directly. So this is just going to be, what is this? RSA and hex. This is a 0 terminated buffer. So these need to be null terminated. And then we can just pass them in as we have them. So this is going to be a pointer, and this is n hex and e hex, boom, boom. This needs to be lowercase null in this language, and we get some return from this verification thing. Message hash. Where did this come from? Where did this come from in our test C? Oh, this is just the fucking string that we're trying to verify. So this is just the sig. No. What the fuck? Do they... So our message comes in as this. We pass in message... Oh, I see. We run the SHA-256 manually. Sure. Okay. Fuck it. Blaze it. So here we do this. Comes from... Oopsies. I'm in the wrong fucking function. Or wrong file. User info. What the fuck, man? Fine. We'll copy paste it again. We will copy paste it again. We compute the SHA-256. So this looks something like const hash is equal, you know, something like this, undefined, and then we can run this from here where we say that our message is message pointer, message len into hash. Which should, I guess here this is message, yeah, it's like this. Yeah. Then we pass in this hash len, I guess is just message hash len, probably. Signature is, we called it sig. So here we do sig pointer and sig len and RSA, and then there. Then we have to like verify this thing in some way, probably. So in our example here, we returned the return value, and then we said if it's 1, it's valid. So if ret is not equal to 1, return error invalid signature. There we go. And then this should be a defer free up here, wherever the fuck we make this thing. All right. So this might work, maybe. Let's start by just calling this function with the hard-coded strings that we have in that we extracted from the key online somewhere. I don't remember. We pulled it from somewhere. And so here, just before we do any of this stuff, let's just verify the thing. So we'll say, oopsies, const this, const that, and we say JSON web token verify this token with RSA n hex and RSA e hex. Boom. Boom. And this is n and e in the right order, so we will zig run or zig build and run this thing. He's going to say error union is unused, so we hit try here. We'll error out if it's wrong. Expected 3 arguments, found 2 at 154. So we did something fucking stupid. We need to write the type of this thing so that it only compiles one of these. If you've ever wondered why Zig makes you pass in the type here for these like std mem things, it's because basically it's a way of like deduplicating function definitions in code. So if you were to do like std mem like my function, and you have like, you know, const s is a slice of u8s, and then you have like const s2 is, you know, a array of 5 u8s, right? If you pass these both into some function that was like variadic and let you like pass in whatever, you would pass this in as like s2 and s, like this. And that would actually create two functions, like two copies of the function, just because it has like this type is different. And so by passing the type in here, you can then say like this, and this ampersand s2 will now like coerce it into a slice, and you will only have one definition in the code. But that took me a long time to figure out when I looked at this. I was like, why the fuck are they doing it? And it's like the same reason you do the same thing in C++ templates, because you have like the same problem can occur. I mean, it could coerce its own internally. Yeah, I think that you could do probably like function wrapper that takes in any type, and then like wrapper internal u8, and v or something, right? You could probably do something like this, but I don't know if like it's not really necessarily worth it. It's like a lot more like writing bloat, and then I don't think that. I guess like you would probably assume that all of that stuff would get inlined anyways, so it would be like probably pretty free. But I don't have a problem with just typing U8 here. I imagine that it's like the maintenance burden of like having to do all of the like meta programming to make that work okay is just not worth it in their eyes. That would be my guess, but what do I know? What do I know? We are not linking against openssl. So here we just need to say user info link system library SSL, and I think it's SSL and crypto, I think. You also think it's for the explicitness? I can see that. I can see that. Okay. C import failed because we don't have libc. Give him a sec, he's got to think. Compile time. Beep boop beep 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 boop beep boop. Okay. We fucked up some of our usage of stuff. So like 172, he found a const pointer instead of a non-const pointer. So probably here we just need this to be variable. Which kind of makes me think that we shouldn't be allocating these here. Kind of makes me think these should be something like this. Because this is kind of saying like, hey, I'm going to take in a double pointer, which means I'm going to set the pointer to something that I allocate, which also kind of implies that we should be freeing this stuff. Oh no, if I remember correctly from my C test, RSA free will free it for us. Yeah. Big num cannot be optional, so this is actually like an optional pointer. Okay, and that 172. These guys can fail, I guess. For now, we'll write this, but we should fix that. And we should also fix it here. Like all of these guys are fix me, validate, return type. Here he expected a C pointer and instead he got a pointer to a const pointer. So I think at 179, we just have to make sure that our message is variable, even though it doesn't need to be variable. No, sorry, which one? Message hash, sorry. This actually does need to be variable because he's writing to it. And then again, there is a value of type this ignored. So I guess we'll just ignore this as well. Expected type C uint found usize. That's annoying, but we can fix that with some casts. So that was on siglen. And are we chilling? Invalid signature. Okay, so we've done something wrong here. Something wrong. So how can we verify? Because this should be like essentially the same thing as what I did in the C side that was working. So I guess we just have to like kind of start working backwards and see what we fucked up. So I guess we can start looking at, first let's validate these guys. So man bn hex to bin. No, fuck. Man open bn hex to bin. Oh, it's hex to bn. Still no. Okay. It's fine. We'll look it up online. So what is its return value? Returns the length of the big endian number placed at 2. Null on bin to bun. Okay, sorry, this is hex to Boom. Return the same number of characters used in parsing or 0 on error. Okay, so we can look here. We can say var ret is equal to this. If ret is equal to 0, return error invalid key. Invalid input, we'll call it. Boom. So let's see if either of those guys are failing out, which I don't think they should be, but oops. Call this RSA ret, I guess. Invalid signature. So we still these big number creations are working okay. Is this working okay? So RSA set 0 key. Fuck. What is the return value of this guy? Return values. Return 1 on success or 0 on failure. If this is not equal to 1, we will say internal error, I guess. I don't think that should fail because of invalid input. And this is succeeding okay as well. What does this return? SHA-256. So this is SHA-256 openssl. What the fuck? Oh, here. Return values, return values. Return a pointer to the hash value. And I guess that like a SHA can't really fail, huh? It's just like rip through the data, make new data. So I don't think there's any reason to worry about that. Okay. So I guess it just makes sense now where we just compare, we just start trying to compare things between the C and Zig versions of the function, I guess. Because I don't think that anything here should be any different. Okay. Annoying, but it is what it is. So let's just first. A SHA is so beautifully pure, a Haskell dev would marry it. Yeah, yeah, for sure. Okay, so let's maybe start with making sure that the message is what we expect. So let's std debug print message is this long and this content. And we will look at message len and message here. And we'll do the same thing with signature. So here we get a message that has the dot in it. Oops, I've been new line this. Oops. So here we have a message that is 379 long, and it has the first dot, and then it ends in a 9. So that matches, it should match here. This has the 1 dot and ends in a 9, which is good. And let's here do a printf message len is message len. Let's just make sure on the C side we see the same fucking shit. Is it LU? Is that what I'm supposed to do here? 379. Yeah, so the message seems like it's the same. Let's maybe print out the print out the message hash. That's probably the next thing to check here. As well as the signature. Well, we're pretty confident that this signature is the same. So the things to validate here are what? Let's just double check that we do in fact pass in the message here. So they're taking the signature len, hash, and hash len. Hash comes from running SHA-256 on the message, which is reasonable. And then here they have hash and hash length, which gets set here, hash and hash length. Yeah, okay, I don't see any reason why this would be a problem. Let's make sure, I guess, that these are the same thing. So we're going to say message hash len. message hash is this thing, and this is the data. And this is going to be like the length and message hash here. Fuck. Zig build. That's right. That's right. So here our message hash is 32 bytes long, which makes sense for SHA. And these are the contents of it. And so now we'll just print the same thing in CLAN and make sure that we're looking at the same fucking shit. So for int I equals 0, I is less than SHA 256 digest length plus I. We have print f the number. And the number is hash I. And we will also printf hash len is this number. And that number is this. He's mad. Probably it's like this, and then we printf a new line at the end of this. Is message hash supposed to be null terminated? Maybe? Doesn't seem like it since we're passing len. Yeah, I wouldn't think so. So here we have a hash length of this, and it is 245, 204, 39, ends in 61. So 32, that's the same, and we see 245, 204, 39, ends in 61. I'm pretty sure that these are like the same fucking string. So we know that we have the same message hash. I'm not so sure about the same signature. Oh, I'm a fucking idiot. We have to base 64 decode the signature. Oopies. I forgot that part. Because in our version here, we basically, like, I did the base 64 decoding of the signature in Python and then copied in the decoded version. So we just need to do that same thing here. So this is like this. Which means we need an allocator. Which means that this is this. Boom. And then we need to defer alloc free sig. Expect 4 arguments, found 3, so whatever we call verify, we can write alloc here. Invalid padding, so what the fuck? Don't we fix the padding in our... I thought we like, oh, we didn't fix the padding here. Fuck, we fixed the padding before. That's annoying. That's annoying. So what we'll do instead... it's fucking fine. It's fine. I guess we will... Oh, how do I want to do this? How do I want to do this? We, like, have the padded thing somewhere else. But... Can I just, like, do this? Signature. We'll do it like this. Yeah. Yeah. There we go. Yep, that makes sense. Segmentation fault? Somewhere? Because did I free the signature when I was supposed to? Because it looks like the verification was fine. Maybe it's from printing? Yeah, this is from a print of our JWT. So it's seg faulting trying to print the signature, which makes sense because, well, this we do free on error, but we don't free on success. But also we don't really have to stash this thing anyways because we're only using it for verification. So we can just delete that field and maybe it kind of goes away. There we go. And then we should actually we should free that thing all of the time. So here it should be free. No, defer, sorry. Which also made sense because we weren't cloning it and the signature was coming from like a reference to something. Yeah, it was coming from this reference to this array that was freed at the end of the scope. So it makes sense that it was breaking. Okay. Double free, not good. Not good. It's good that this catches it though. That's super sick. And so this is double freeing the signature probably. So here we're JWT segment decode signature here. The fuck? First free comes from inside verify, and the second free comes from in parse. Oh yeah, so just in verify, I was freeing a signature that I don't own, which is fucking stupid. Oopies, I just didn't delete this line. My bad. Oh, we also don't need the allocator here anymore, which is sick. And then just as confirmation, if we tamper with this thing in some way and we change one of the characters, so say we just come in here and we say, maybe once we copy it out, we just say like, how can we tamper with this? Var new JWT is alloc dupe JWT. Yep. Defer new JWT free. And then we'll use new JWT here just to make sure that everything is still hunky-dory, which it's not, because here I need to write U8. And I also need to write, oops, no, the U8 comes here on the other one. Not bad. Not bad. It's okay. Okay, so that works fine. And then if I just say like new JWT 4 is equal to 3 or something, right? Like just really, maybe we'll make it like a character that's valid base 64. It does give me invalid signature. We did it. We did it. We validated our JSON web token. That took a really fucking long time. But we fucking did it. We did it. Okay, so there are elements of this web token that we have to verify as well. So we have to make sure that like the algorithm matches. So I guess that's kind of part of verify as well. So maybe we will pass in the web token. So we'll call this parsed is a JSON web token. And then we in here have to check some things like parsed header algorithm is equal to RS256, I think is the algorithm that we are supporting right now. Return error unsupported. He doesn't like that. This has to have a U8 on him. I guess we need to actually correlate this with the keys that are given to us by Twitch's like ID configuration. So maybe let's do that. We'll say that it is at 014900, and we'll say load Twitch JWK. This is the key from Twitch. And so here we're just gonna do, maybe we can like copy paste their key from somewhere, or maybe we can curl it and stash that somewhere. So it's like a somewhere in here they tell us about like well known. Here we go. Copy paste this. and then we will go here, and then we will kind of just curl this into some file. Or maybe we'll just do this. We'll just copy paste it. Yep. Yep. What a concept. I can use myself. So here we'll say const twitch jwk is this thing. This is what they will give us. I guess we will maybe do this so that we don't have to worry about string escaping. And then I guess we will say we have to parse this thing as well, which is fucking annoying and gross, but it is what it is. It is what it is. Okay, what is in this thing? Alg, e, kid, kitui, and n. And use. Alg, e, kid. So this is what algorithm they use. This is the exponent field of the RSA thing, the public exponent. This is the key ID, which is a constituate. Key type. Not to shoo away my own viewers, but for somebody saying, how can I learn coding? And somebody else very nicely in chat said, keep watching, which is a very funny answer. I will say that I don't know if my channel is really the best beginner-friendly channel. I think that, you know, it could be useful if you wanted to see how somebody kind of that's like a few years in is working, but I might be talking about a lot of stuff that kind of flies over your head. Now, I will say that like exposure to concepts is kind of nice. Like just knowing that things exist is like a good thing to be aware of. But if you're like, how the fuck do I write a function? I don't know if this is necessarily the best use of your time. I will say that what is a good use of your time is just making stuff that you feel like you are like motivated to make, right? So find a problem for it that you have, right? Like if you're like brand fucking new, it could be something as simple as like you want your files named a certain way and it like pisses you off that you have to do it by hand, right? Just like anything that gets you like making something that solves like a real problem, because like by solving real problems you will encounter like things that you need to learn, and then you just learn those things and you keep going. That's my opinion anyways. Yeah, okay. So this thing has all these fields. Were they all strings? I think they were. String, 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 string. Yeah, chillin'. N looks like this is base 64 URL encoded. Right, so both N and E are base 64 URL encoded. So we have to do base 64 URL decode on both of these. Here we just need to make sure that the algorithm matches. I guess here we will check RSA, what is it? RS-256 is like the only key we support right now, because we're like manually running 256 SHA-256 and RSA, so that's like, this needs to match. And then this, we need to correlate with key header in our web token. So that's, this key ID has to match that key ID. What is key type? Key type is also, I guess this we need to just validate equals RSA. And what is the use? The use is sig. So I guess here, ensure validate equals sig. I think that's reasonable. I think that is reasonable. So maybe we will make a function that's like, let me think here. So I think that we're gonna like also have like RSA params, right? And these are gonna have like the decoded versions of N and E. So like here, these are base 64 URLs, and here we want these to just be like their actual bucket of bytes. So we'll say these are like decoded. Ready to use in openssl, which means that these have to actually be null terminated, because openssl is expecting null terminated strings for these parameters. And then we can just make a function here that's like parse, that takes some like string in as its like input data. So this is JWK, and this will return an RSA params. Because these are really the only pieces that we care about. Everything else will be done like by checking on the fly. So we'll say first we have to parse this thing with JSON. So this comes from maybe this. We parse this thing from a slice, but we parse it as a JSON web key. Yeah. We need an allocator as well, I guess. And this is going to be from Jawuk. We're chilling. Okay. Then we just want to start checking stuff. So let's start by return error unimplemented, and we'll print what we get, just so that we have some proof of something being on the right track. I don't like getting too far without compiling and seeing some progress. I actually see people online bitching about this type of workflow. I've seen people like on Hacker News being like, kids these days, they don't really know that their code will work until they run it, and so you have them like rapidly compiling nonstop. I'm like, dude, I'm fucking all for rapidly compiling nonstop. It means that there's less that can go wrong, right? Like you just like turn your like debugging from like this like n squared tree of like, you know, there's like, I've made this choice, this choice, this choice, this choice, and I validate them all at once, versus like validating it every once in a while, like just a few things one at a time. I like that. I like that. Okay, so we'll say, I guess const parsed or RSA params is a JSON web key parsed with our allocator and our Twitch JWK. Then why not auto build on save? I don't like when my computer does things without me asking it to. Is the answer. Like sometimes your build is just like not like rapid phase, and like, you know, it like just does. Like I don't like it when things are happening that I didn't expect. Okay, so we have to maybe do something with this. We'll just say this, and we have to write try here probably. Okay, missing field. Okay, so we are already at a case where it's not doing what we expected. Missing field. Are you fucking kidding me? Oh, fuck me. So we actually, we have, this thing comes in as a bunch of these things. So it's like this. No, it's keys : array. Oh, that's annoying. So here I guess we'll call this JSON web keys. And this is going to have a keys field that goes to a bunch of JSON web key. And I guess here, yeah, let's do it this way. So here we'll kind of throw the RSA params in here, and then instead of returning one RSA params, we'll maybe send many of them, as well as keeping their key IDs. Sometimes you don't want to compile when saving because you know it won't compile anyways. Yeah, that's true. I have that all the time. Yeah, okay, so this will parse a keys, plural. And then we'll figure out the rest later. So this has to be JSON web keys parse. And okay, so that gave us an answer. Now there's a bunch of leaking going on here, which we have to fix. So here we'll just say message parse dnit here. And I think that's probably all of the undefined memory or the unfreed memory is just from that. It does look like it, yes. Okay. Okay, what is next now? So now we need to iterate over the keys. So for key in, we'll just call this parsed, I guess. For parsed value, each key, we are going to do something. Which I guess could just be key dot validate. Yeah, let's do that for now. So here we will have some function validate. self is a const JSON web key is probably fine. I guess we could take it even by value, because who fucking cares? Zig will figure out what is more efficient. And this is going to return an error on invalid. So we'll try here. And then we can just say something like, let's do something stupid first. So if std_mem equal alg, if this is not equal to ASDF, we should throw an error, right? So here we should say return error invalid. And maybe he'll even say std log error unsupported. I guess this should be unsupported, to be honest. Unsupported alg, and we'll even write the name. Like nice citizens of the world. This is self.alg. And so now we expect failure. Except instead, this needs to be on keys. And we do see unsupported alg rs256, but we know that we do support rs256. So we will just write rs256 here, and it should pass again. Now we have error unimplemented at this, which is fine. This is what we expect. Okay, so E and N we need to decode. KID we just need to propagate along. And so key type and use is the only things that we need to check here. So here we have Kitui is RSA. We have use is SIG, and we have to adjust our messages. So we'll say unsupported key type comes from Kitui. Is error special in that you can conjure up enum members just by referencing them? Is this done for any other language construct? I think yes and no. So like to your two questions. Like error is, I think that like you're not supposed to type error like this everywhere, but you're supposed to like create error enums and use like direct ones. You're supposed to say like const my error is equal to error union like with A, B, and C or something like this. But this is like errors have all this like special stuff where you can like or error lists together, right? Like stuff like this. And I think that this is like just more special syntax where it's like you're making like a union of that only has one value unsupported, and then like it will automatically kind of like or those things together under the hood or something like that. Yeah. Okay. So this should validate okay, which it does. And now all we have to do is maybe have a function that's like get RSA params. So maybe RSA params will just kind of live out here. And this will return RSA params. And this will take self. And I think that we're going to have to dupe the key ID. So this is going to have to take an allocator as well. Pretty sure it just throws everything in a global error union. Ah, okay, that makes sense. That makes sense. So this is something that is failable because allocation can fail, which is a nice thing that Zig does for us. E is going to be our JWT. Where is this like JWT decode function that we wrote? This needs to get pulled out because these things are encoded in the same way, I think. Which means that we're gonna have to actually rename this later, but for now we're gonna leave it as is, and I'll just try to fix me rename. So this gets, this is like try JWT segment decode of allocator and self E, and N is the same with self N. That is the same. What is he coding? Let's see if we can demo it. Ball machine. Good, everything compiles. So we are working on this collaborative application where we have this like physics simulation of balls, you know, going and hitting like platforms and stuff. What is special about this thing is that the environments, like these platforms, the platforms being rendered by a WebAssembly module that's sitting in my browser, as well as the physics is running the same WebAssembly module on a server somewhere else. And so the idea is that users will eventually be able to write their own WebAssembly modules that conform to this special API that says like this is a chamber, and they'll be able to like upload these WebAssembly modules, and we will run them as like one giant simulation, right? So right now these are like independent chambers. These chambers will be linked together and we'll make like a giant Team Rube Goldberg machine. And today we are working on trying to like figure out how to like authenticate you guys, right? So you guys are like, I have a WebAssembly module, I want to give it to you. I need to know who you are in order to accept that, so that I can like credit you and like ban you if you do something that I don't like. Yeah. As well as like we're kind of like using Twitch as a way to throttle the amount of like accounts that someone can create, stuff like that. Stuff like that. And right now we're looking at just validating the ID token that Twitch gives us, which is a pain in the ass. Massive pain in the ass. I don't like it. But, you know, we have to live with what we live with. Okay, so here we should be able to like up front know how many RSA params it has. It should be 1 per key. So we'll say var ret, const ret, is an allocated set of RSA params that is the same size as the number of keys we have. Yes, like this. And then for each of these, we just say, we'll take our index and we'll say ret I is equal to key get RSA params. Easy. Now we have to be a little careful, because if this fails, we need to say error defer alloc free ret. And here we should just be able to return ret. And now we should have all of our RSA params, to be honest. Fuck. 29. This needs to be tried because allocations could fail. Fine, I get it. Member function expected 1 argument, so I think this needs an allocator. Which kind of indicates that RSA params needs a dinit function. Yep. Which is going to dinit the key ID that we copied. So this is going to be alloc free self key ID. Boom. I guess this can technically be const without being a problem. Which then also means that this I variable should be tracked externally, so that we know how many things that we have fucked up. Right? So if we get through 2 of these and the 3rd one fails, we need to free the earlier 2. So here we need to say, you know, I plus equals 1. And then here we say error defer. If something goes wrong, we have to loop through all of these values and free them. Chilling. Man, keeping track of the auth flow is pretty confusing. I know OIDC is pretty much auth and the user's J2E. Dude, it took me... I feel like I'm like fucking smoking crack trying to understand this stuff. Like, I feel like I'm like, not to toot my own horn, but like fairly competent and fairly quick at picking stuff up. Like those are like, I think like some of my strengths. And like reading through this like OpenID stuff, I was so fucking lost, man. And I couldn't believe just like I feel like a lot of my way of thinking comes from being like, okay, what exactly is this thing? And like it just was so hard for me to pull out the information of like what is actually happening in when we're doing OAuth. Like tell me what each exact step actually does, and it's so hard. It's so fucking hard. I think ideally you need to find a mental model that matches the thing you're doing. Yeah, that makes sense. That makes sense. Okay. So here we have our parsed keys, and so here we should be able to like log the keys that we got. So here we should be able to be like const maybe std debug print any of these RSA params. Fuck. So 75, we need to write what we're duping, I guess. So this is a dupe of JSON const u8. No, u8. Dupe of u8 only. Expected type this, found that at 76. So these guys, E and N, Can I return a null terminated thing from here? Can I do this? Like, is it Alex0? Alex Sentinel, I guess. Is there no like Alex Z? No, okay. That's fine. So here we will, in here, Alex Sentinel, and here we'll just write a 0 here, I guess. And is the Sentinel included in the size? N+1, no, we're chilling. Oops, wrong command. We're trying to run user info, our debug thing. And we're mostly there, except we fucked up with some leaking. With an invalid padding thing. Oh, fuck me. So this thing needs to handle the pad. I think that we should just change this function to like pad the things if it needs to. Let's do that because this is fucking annoying. This has come up like more than once. So we'll take this like padding stuff where we say how much does this thing need to be padded. We will calculate it. And then we will say const new if fuck it, we'll just unconditionally clone it. I don't give a shit. So we'll say const padded is alec.alec data dot len plus the number of padding characters needed. And then we will go from data.len to data.len plus this, and we will set padded thing to the pad value of equals. So padded I is equal to equals. I guess we could do a mem set here. So padded kind of like this shit is padded with this shit. And then we have to mem copy padded from 0 data len into from data. There we go. There we go. That should fix it. Data items len is the wrong thing. It's just data len. He doesn't like that because padded needs to be failable. Other viewpoint, constructing a mental model on an abstract thing you don't quite understand is called making assumptions, which can be dangerous when dealing with cryptography. I will, yeah, to some extent. I mean, like, you have to build up mental abstractions somewhere, right? Right, like, you can always keep drilling down, and somewhere your mental model will break down, right? Like, RSA, you know, like, SHA-256, right? I was looking at this yesterday, actually. I was trying to decide if I wanted to go down this rabbit hole of, like, how far do I want to understand this stuff? And I was kind of, like, looking at, like, this implementation for SHA-256, and I'm like, you know what? I don't need to get it, right? I can like understand that there is some sort of state machine where they're like adjusting numbers as they go, but like in reality, I can trust that the math behind SHA-256 is good enough, and right, like I can like kind of be aware. I can like look at this and go like, you know, if I needed to understand this a little better, I think it's possible. I could like dig into it, but I don't have to, and I can just build the mental model that SHA-256 will generate a cryptographically secure hash of some input, right? And so like. You need to build the mental model somewhere, and I think that like you just need to figure out where those barriers make sense for like your current viewpoint, right? But I do trend towards more likely to dig deeper, right? I think a lot of people trend more towards like trusting libraries. I think I very rarely trust libraries. It just depends. Okay, so this should now be fine. Oh, I didn't use padded here either. This needs padded as well. Now we have some leakies to deal with because I probably just didn't free this thing. So defer alec free padded. What else am I missing? Alex Sentinel, wherever the fuck that is. JWT segment decode here. Right, because our RSA params need to free those things. Okay. What else is not working? So, do I not free the parameters here? Yeah, I guess I need to go for defer for RSA params dot.dnit with our allocator. Does that fix all of our leakies? Most of them. Just one left at 308. Oh, and then I need to RSA alloc free RSA params as well. Gross. Okay, there we go. So we have RSA parameters that we have parsed out. And so now we can say that when we verify our JSON web token, we will pass in our RSA params as one of the inputs. So here we're going to have RSA params is a list of RSA params. Probably constant makes most sense here. We're not going to modify those things. And here when we verify, instead of passing in N and E here, we should pass in RSA params. Then here, we can basically look for the parameters that match our key ID. So we can look at well, first we have to adjust this. So this N and E is now coming from RSA params, which is a bunch of RSA params. And we can just say const, maybe we'll call this RSA params list. And then we'll say RSA params, which is the one that we're going to use, is equal to undefined. I guess maybe we'll do like this. We'll call it RSA params opt is equal to null. Then we will loop over RSA params list. Right? And we'll say if std_mem equal params KID and parsed header KID, this is the one we want. So we'll say our RSA params opt is equal to params and break. This has to be variable, so we can reassign it, and then we'll say if RSA params opt is equal to null, we can return error no key. Chillin'. Then we have this that we were verifying, so we verified the algorithm is what we expect. The type, what is the type here? Tip. Can we maybe write GDB break 199. So this is unused, fine. I guess we should comment them out just in case. And we are looking for 279. Right, so here we need to actually use params RSA. Here we will say that the const RSA params is equal to RSA params opt dereferenced, which means that here we can say RSA params end pointer and RSA params e pointer. We chillin'? Not quite. 253, we expect this to be a U8 equals. Okay, and then I wanted to check what our header looked like here. Run, and then print parsed header. What are we looking at? We have algorithm, RS256, type, JWT, kind. Oh, I see. So here we should just say that our, we will also verify that the type is JWT, and then everything else is good to go. Good to go. So then we verified the signature is good. We verified the header is good. And we haven't really verified any of the parameters in the message, which I think we also are supposed to verify in some way, shape, or form. Right, in here, we're supposed to look at these things. So I think our nonce is supposed to match what we sent. I think one of these things is supposed to match like our client ID. This is, one of these things is like, I think ISS, I think is the issuer, so that we have to double check that this is like Twitch. But I don't think there's any point in getting into this right now. I think that like we can kind of say we have validated a JWT token. I think we've done most of the necessary work here. I will stand by that. I think almost everything that we did today is not necessary, because I stand by the fact that because we are asking Twitch directly over HTTPS for a token ID, or like an ID token, that like verifying again that the ID token came from Twitch feels insane to me. It's like we fucking know it came from Twitch. We just asked them for it. JWT token, oh no. You're right that I shouldn't say JWT token. That's not what you mean, I'm pretty sure. But it's like saying ATM machine. It's JSON web token. So anyways, like I feel like there's no point, but it was a fun exercise. I think we got a fair amount done. I feel like it would be nicer if we didn't spend so long on like the JSON parsing and stuff. There was some like bullshit happening in there. The RSA stuff is like fine. I think it's fine to like build up. I don't feel like I have the like muscle memory for how to work with RSA, and so like getting this down feels okay. I will probably off screen try to upgrade this API to use the non-deprecated one. I think I saw here, because openssl was bitching at me when in the C version. He's like, don't use these fucking functions, man, they're deprecated. So I'll have to fix those. But yeah, I think we'll be back tomorrow with now that we have these two pieces, we should be able to start doing the interesting and useful work of well, useful is a stretch. Nothing that we do here is useful, but we will be able to start working on like the more interesting work of, once we have this user's ID, what do we do with it? How do we make sure that like it displays to them that they're logged in? How do we attach that to like data in our database associated with those guys? But I think that we're already at 2 hours and 20 minutes, so I think we will call it there. Thanks for watching, guys. If you like what you saw, we stream most days at around 2 o'clock Pacific time for around 2 hours. Today we're working on like this like long-term project of this like ball machine. Right now we're working a little bit on like authentication. But we will get a little farther. What do we have? We have some like WebAssembly chamber development to do. We have some like stitching of chambers together to do. We have some like UI stuff to do. So there's a little more work there. We'll probably be on this for a little longer. But I will say that like if you're not specifically interested in the project itself, it's a good excuse to explore a lot of things that we haven't explored before, right? Like OpenID and stuff like that, and like async HTTP servers. That is all kind of like under this, even though it is not technically the project. So anyways, if you're new here, there is a YouTube link in the Twitch description where you can swing by and you can check out all of our previous projects. So there's a lot of stuff in here. Basically, we trend towards low-level stuff that I feel like learning about. So operating system, neural network, terminal emulator, zlib reimplementation, QR code decoder, stuff like that. You'll see that around, so check it out if you care. There's a GitHub link in the Twitch description as well, where code for all of our long-term projects does eventually end up. And if you're watching on YouTube, you can swing by if you're online between 2 and 4 Pacific time. There should be a Twitch link in the YouTube description, so swing by if you feel like it. Like, subscribe, Twitch Prime, and I think that's it. Bye, YouTube. Twitch, let's raid somebody.